Hello everyone. In this video, I will go over the solutions to participation number one. So the first part of the participation one consists of calculus one review. So this is just to refresh your memory and make sure you remember calculus one, which is very important for calculus two. Question one, part A, is asking you to find the derivative of this. So you notice here you have technically one function for sine, the 4 power, that's a second function, and for x to the 5th power, that's a third function. But this is a single function, so there's no need to use the product rule. This is just the chain rule. So therefore, f prime is going to be 4 sine q of 4x to the 5th times the derivative with respect to x of sine 4x to the 5th, which if you apply the chain rule again, it will give you cosine of 4x to the 5th times the derivative of the inside of cosine, which is 5 times 4 is 20, so it will give you 20, then x to the 4. So finally, if you simplify all of this, you will end up with 80 x to the 4 sine q of 4x to the 5th times cosine of 4x to the 5th. So essentially, you have to apply the chain rule twice here. Now, part B is pretty similar. It's also the chain rule only, though there is no product rule here either. So here is very important to understand that n is a constant, and by constant, what I mean is the following. So if you have like x to the 4 is a constant, so the derivative x to the 4 is just 4x cubed. So it was x to the n, it will be n x to the n minus 1. Okay, so that's just a side note. All right, so here, now you actually have more than 3 functions, and you'll see that right now. So here, f prime will be the derivative of g to the n power first, which is related to this. So this should be n g to the n minus 1 evaluated at tangent x squared times, by the chain rule, g prime evaluated at tangent of x squared times, we need the derivative with respect to x of tangent x of x squared. Let me write this correctly, of x squared. So then you simplify this part by itself. The derivative of tangent, remember, is secant square of x squared times, you have to use the chain rule one more time, the derivative inside, which is 2x. So therefore, you simplify everything. From here, you will have the f prime. It will be 2nx or xn g to the n minus 1 power evaluated at tangent of x squared times g prime evaluated at tangent of x squared, and finally times secant squared but evaluated at x squared. Now let's move to number 2, which is dealing with a review of integration. Specifically, we're going to focus on u substitution. So that's what we need to worry about. Let me pick the correct size for this thing. All right, so here Remember the tangent and secant are related in many ways, but one of them is the derivative of respect to x of tangent is equals to secant square. And the derivative of secant is actually secant tangent, okay? So therefore here you see you already have secant square in here. So therefore that can help us to identify that u should be tangent x. So therefore if we let u to be equals to tangent ax, actually where a is a constant, so then du will be secant square of ax times a by the chain rule, which is essentially a secant square of ax. So if we use substitution, this will be equals to uq, because u is equals to tangent of ax, so it will be uq. The du is going to take care of the secant square ax, but notice that you end up with an extra a in here. So to cancel that out, you multiply by 1 over a, and then this is just a basic integral. So this is equals to 1 over a. You apply the most basic rule of integrals, which was this. Remember that you have x to the n. This is equal to x to the n plus 1 over n plus 1 plus a constant. So this should be u 3 plus 1, which will give you 4, divided by 4 plus a constant. And then finally, just rewrite this in terms of x. U, it happens to be tangent, so it will be tangent of ax, the whole thing to the 4 power plus c. So this is perfectly a good answer, but this is usually written like this: 1 over 4a tangent, the 4 power goes here. This is just different notation, but it's exactly the same thing. Okay, so now let's move to part B. Here, since we're using a substitution again, you technically only have 2 choices, okay, for the substitution. You could use, for example, u equals to 1 plus x to the 6, but notice that if you use this substitution, du will give you 6x to the 5th, but you don't have x to the 5th, you have x squared, so this is not going to work. So therefore this is not a good choice. Now if you use u equals to just x to the 6th, you're going to end up with the same issue. So this is also not going to work. So therefore you had to rethink the strategy. And if you notice, okay, so notice the following: the x to the 6th, you can rewrite it as x cubed squared. And if you let u to be x cubed, the derivative involves x squared. So therefore this should be the substitution. So therefore what you should say is let u equals to x cubed. So therefore the u will give you 3x squared, the x, and then when you plug it into the formula using this fact too, that this is true, this is equals to the integral of the u over 1 plus u squared. This is one of the most classic integrals, which means it's one of the most common integrals, and you should memorize this by now if you didn't do it in calculus 1. And this is just tangent inverse of u plus c but u happens to be xq. So this is tangent inverse q plus c, and that's it for that. Now let's move to the problems from section 6.1 to 6.3. These problems are actually only from section 6.2. So the question is asking you to find the volume generated by the region R that it will be formed by these two functions or lines or curves. So the first thing we will do is create a graph. The graph should look something like this, and you need to figure out the intersection. In this point, it's actually clear. For this example, the intersection is 0, 1. But if that wasn't clear, to find the intersection, you just have to set the two equations equals to each other. So you'll have to have x to the 1/4, which is the 4 root of x, minus x equals to 0. And then you will factor the smallest one, which is x to the 1/4. This will give you 1 minus x to the 3/4. And the answer to this one will be 0, and to this one it will be 1. Okay. The method, the question is asking you to use the method of slicing, which is also called the washer method in this book and other books. And the formula for that is the following. The volume will be the integral from 0 to 1 in this case, or whatever the area is, the x. Now to figure out the area, that's where a partition is very, very important. By a partition is, I mean this. The partition for this method has to be perpendicular to the axis of rotation. Notice that y equals to 0 is just a fancy name for the x-axis. So this is being rotated here. And the distance between here and here is x. Okay? So therefore the volume is going to be pi. By the way, here the area, this relies by the area, this relates to the area of a circle, so it should be pi r squared. So the pi has to be part of the answer. This is 0 to 1. And then this will be the biggest function, which in this case is this one, which here you should know that this is the 4 root of x, and this one is just x. So this should be the 4 root of x squared minus x squared. And once you distribute, this is equals to pi, the integral from 0 to 1 of x to the 1/2 minus x squared dx. And this is actually pretty easy to integrate, so this is equals to 2/3 x to the 3/2 minus x cubed over 3, and the limits of integration go from 0 to 1. And you should check this. Once you get this, this is pi times 2/3 minus 1/3, which is just pi/3. So therefore this is a volume, and it will be in cubic units. Okay. So therefore if you rotate this area around this axis, you will end up with a volume that has pi/3. Part B is asking you to rotate the same area, but instead of doing the x-axis, it's asking you to do now to do it around the y-axis. If we draw the same graph again, this is what we have, exactly the same thing as this one. The only difference is that now we're rotating on the y-axis, so the rotation will go this way. And remember that the axis of rotation has to be perpendicular to the partition. So now this will be the partition. Notice that the distance from the center to the partition is technically just y, you think about it. Okay, so therefore in this case we're going to have to integrate with respect to y, and notice that if y is equals to x, well, that one is obvious. X is equals to y, so there's not much to solve in here. But if y is equals to the 4 root of x, that means the x is equals to y to the 4. And notice that now if this is the partition, this is the bigger function and this will be the smaller function. So therefore, using the exact same method, the volume now is going to be equals to the integral from 0 to 1 of pi, and then y, which is this one, but square, minus y to the 4 square, which will give you y to the 8. So this will be pi, the integral from 0 to 1 of y square minus y to the a, which again is a pretty easy integral. So it will be pi times 1/3 y cubed minus 9 y to the 9, and from 0 to 1. And you can check that this is just 2 pi over 9. Finally, the last one is a little more tricky, because you're revolving around y equals to 1. So first, we draw the exact same graph again. This is the area that you are going to rotate, same area as the previous two problems. You are rotating on the line y equals to 1, which is technically similar to rotating on the x-axis. You just move the x-axis 1 unit up. Okay. So this is the part where things get a little more interesting from this one. So you have the partition, and you look to the center of the partition, and from the center of the partition, which is somewhere here, the distance to here is now going to be technically 1 minus x. So therefore the volume, using the exact same formula again, is going to be still the integral from 0 to 1 of pi. But now, since you are rotating right here on this line, the distance between the partition and the axis of rotation is going to be 1 minus x, and you have to square the whole thing, and then minus, this is now the smaller function. So if you are rotating here, this is the bigger function and this is the smaller function. So then this will be 1 minus the 4 root of x squared dx. So if you distribute, you will end up with pi, the integral from 0 to 1 of 1 minus 2x plus x squared using FOIL, minus 1 minus 2x to the 1/4 plus x to the 1/2. And if you combine like terms, you end up with pi, the integral from 0 to 1 of x squared. Notice that the ones will cancel, so you will have plus 2x to the 1/4 minus 2x minus x to the 1/2. And each of these terms is very easy to integrate. So when you integrate, so you should check on that. The integration is pretty simple, and you plug in the values of integration, you should end up with 4 pi over 15. And that's it.